All right, we're back. We're still on page 100. We're going to move on to like a slightly different application of this stuff, and that is solving trig equations. And so this is going to look a little weird to you initially. So what I like to do is I like to do an extra step where I make it look exactly like the formula that I have memorized. And you don't need to do this, but I think it's useful. So I'm going to rewrite this using the lasso tool. I'm going to rewrite this as cosine of x cosine of pi over 3. So if there's a variable, I like to move it to the front, and then I like to match things up so they're in the same like relative position. So like AB type of situation. I'm trying to say situation, it's not coming out. All right, we got this. All right. Now on this side, the left-hand side, I see x there and there, and then I see like y there and there, whatever, right? You could say cosine A, cosine B minus sine A, sine B. So this is definitely the cosine of A plus B. So this is the cosine. I don't know where to, I want to like line it up. So cosine of x plus pi over 3 is equal to negative root 2 over 2. And now we know what to do, right? So we're thinking like cosine of something is negative root 2 over 2. So that's something. So x plus pi over 3 is going to be 3 pi over 4, or x plus pi over 3 is going to be 5 pi over 4, because that's where cosine's negative, quadrants 2 and 3. So this, I'm thinking in, we got to generalize. What am I even doing? Get out of here. Get out of here with your commas and stuff. There we go, plus 2 pi n. That's why I put a comma there. I knew like, whoa, where are we going? Let's come back. I knew that there was supposed to be a comma, and my brain was like, just do it, just put a comma. So I did. All right, here we go. So x equals, it's 9 pi over 12 minus 4 pi over 12 is 5 pi over 12 plus 2 pi n. And then it's 15 pi over 12 minus 4 pi over 12 is 11 pi over 12 plus 2 pi n. And then n is an element of the integers. So I believe that this is our solution. But what we can do is ask the calculator to solve it. And off the top of my head, I do not know how the calculator deals with these. Like, does it deal with them well? Does it deal with them poorly? Let's find out. So I'm going to check this one and see what I get. So I want to solve cosine of pi over 3, cosine of x. You always want to type the original, so that like we didn't introduce any of our own mistakes to this problem. Any mistakes are, they're endemic to the problem. So let's see, solve that. And then you got to do our expanding thing to just like confirm. You can see the 5 pi over 12 one is definitely there. This, and then, because it does the negative thing, 11 pi over 12, definitely there. So we got it. So this is a way that you can use these. And what I want you to do is pay close attention though to the way it looks, because you can make this problem look different because you actually know the values of some of these things. So what you could do is I can't find a different color. You could evaluate the cosine of pi over 3, right? The cosine of pi over 3 is 1/2. You can evaluate the sine of pi over 3, which is radical 3 over 2. So if this problem had said 1/2 cosine of x minus radical 3 over 2 sine of x equals negative root 2 over 2, that's the same problem. It just looks a little different. And you got to keep that in mind, because what I'm going to do is I'm going to mess around with that. That's like my goal. So here, this one doesn't look that bad, and I think it's organized the way I want it to be, right? It's sine, cosine, cosine, sine. Perfect, sine of a minus b. So we got the sine of x minus pi over 5 equals radical 3 over 2. So I'm just thinking sine of something is radical 3 over 2. So that thing could be equal to pi over 3 plus 2 pi n. Almost forgot it last time, tragedy. And x minus pi over 5 could be equal to 2 pi over 3. We're going to check them. So, and I'm saying that to like reassure myself. All right, so simplify this. we're going with 15ths. 5 pi over 15 plus 3 is 8 pi over 15. And then plus 2 pi n. And then this is going to be 10 pi over 15 plus 3 is 13 pi over 15 plus 2 pi n. And then for all of them, we need n to be an element of the integers. And then for whatever reason, I like to highlight these answers. I don't know why. Now, I don't know the sine and cosine of pi over 5 offhand. You can find them, though, in some weird way. But I don't know them offhand. And so I'm not going to be able to rewrite this. But if you knew them, you would be able to rewrite this also. Like if this was, I don't know, 13/20ths or something, which is definitely not. You could replace this and then whatever, replace this, and make it look like sine of x times some number minus cosine of x times some number equal to thing. We could still do this process. And that is where we're headed, which is why I keep kind of like trying to hammer that home. So let's see if we can solve this. Solve sine of x, cosine. So since it can find the cosine of pi over 5, I think that it might mess this up. It's like one of those, like a little knowledge is a dangerous thing, because you need complete knowledge to really be able to like deal with this sort of thing. Yeah, this is a mess. What the? All right, so how to check. So I'm gonna do this. Let's pull out this part. I don't know if I'm ever gonna be able to get it to do it. I'm gonna do such that x equals, can I like t collect this? No, I can probably not t collect this. Nope. But what if we change these to y's? Yes, let's do that. Here's a y, here's a y. Okay, and then if I do such that, so x is gonna have to be 8 pi over 15, and y is going to have to be pi over 5. And it works. And then if we change it to 13, it works. So we got it, but checking it is like a super roundabout thing. That's unfortunate, but you know, you got to work with the technology. It's not, there's a really good chance Wolfram Alpha, if you type it in the website, wolframalpha.com, that might solve it. And you might not have to worry about that. But who knows? All right, let's try this one. So here, step one for me when I do these problems is to rewrite them so that the variable comes first and that it starts to look like a formula that I know. So I'm going to say cosine of 2x and then just this radical 3 over 2 plus sine of 2x and then just this like 1/2 equals radical 3 over 2. The number on the right honestly doesn't really matter as long as it's like in the range of sine and cosine. Because of what we're doing. But like, don't worry about that. These problems, you're not given like curveballs. So now I would like to say that this is kind of like, oh gosh, sorry. I thought that was a highlighter. I want to say that this is cosine and then sine of 2x. And then these, so here's the tricky thing. What could these be? Well, what if I wanted to make this cosine, I don't know what, so I'm just going to say b, plus sine. And again, I don't know what the angle is, but by doing this, I just created a weird scenario. I know, because of what I chose, that the cosine of b is radical 3 over 2, and the sine of b is 1/2. So for angle b, I know cosine is radical 3 over 2 and sine is 1/2. So I actually know that the angle B is pi over 6. So look at that. Think about that. That's an important step right there. So really it's cosine 2x, cosine pi over 6, plus sine of 2x, sine of pi over 6, equals radical 3 over 2. And then this cosine plus sine is the cosine of 2x minus pi over 6 equals radical 3 over 2. And now we're just solving this the way we've been solving. So I know that 2x minus pi over 6 should be equal to cosine is radical 3 over 2. So that's going to be, well, that's interesting. Pi over 6 just works. So pi over 6, but plus 2 pi n. Or 2x minus pi over 6 equals, where's the other place that cosine is radical 3 over 2? 11 pi over 6 plus 2 pi n. And then n will be an element of the integers. So if I add this, so I'm adding and then dividing by 2. So I'm going to get that x is, it's 2 pi over 6 divided by 2. It's just back to pi over 6 again. Pi over 6, but then, ooh, not times. Plus 2 pi divided by 2 is pi. And then here we'll get 12 pi over 6 is 2 pi divided by 2 is just pi plus pi n. Pi plus pi n, where n is an element of the integers. Pi plus pi n is inefficient because you could just write just pi n, like, because if n equals -1, it's just gonna give you 0. So 0 plus pi n is the same as pi plus pi n for, for all n's. So let's check this and see what happens. And again, I don't know what we're gonna have to do to make it work, but we're gonna make it work. So I'm gonna first try to just solve it, which like often works. And it's really a blessing when it does, because then you don't have to come up with other weird ways of doing it. 1/2. I'm thinking we might have to do like a such that situation, but this is supposed to equal square root of 3 over 2. Solve that for x. Oh, got it. Okay. So you can see the first one is our second answer, which is just like pi times n. And then the second one is pi over 6 plus pi n, which we definitely got. So nice. All right, let's take a look. We might as well just do the last one in the notes and then, call it a day. I'm saying that it could take like 5 minutes. I don't really know. We'll see. I'm going to try to blow through it in a neat, organized fashion that people can follow when they're learning, but blow through it nonetheless. All right. I look at this and immediately I'm just going to like rewrite it a little bit and say it's sine of 4x times root 2 minus cosine, because I always rewrite it so that the variable, ew, what is that x? So the variable comes first, equal times root 2 equals -1. All right, now, if I want to try to do the same thing, I'm a little in trouble here because radical 2 and radical 2 cannot be the sine and cosine of any angle because they're bigger than 1. But I do know that if I divide by 2, I'll get root 2 over 2, and that could be the sine or cosine. So I'm going to do that. And we'll come up with a more organized way to do this. But sort of the intuitive approach is not something that you should look down on. It's a really good way to like work your way through these problems. So we have 4x and 4x. And now we created this and this, which we're going to say are the sine and cosine of something. So I'm going to say this is sine of 4x cosine of b minus cosine of 4x. And this would have to be the sine of b. Sine, cosine, cosine, sine. Which is why knowing the formulas is really important. So if that's the case, then the cosine of b is root 2 over 2, and the sine of b is root 2 over 2. So we actually know that for angle b, the ordered pair is root 2 over 2, root 2 over 2, and we know what that is. So b is pi over 4. And so we can rewrite this as the sine of 4x, the cosine of pi over 4. So these are not unique. There's more than one way to solve these problems. And again, it's like if you go through the process and you get equivalent answers to our answers, then you did it right. You just did it a different way. That's not a problem. Sine, cosine minus cosine sine is the sine of a minus b. Look at this, equals -1/2. And we're almost there. So 4x minus pi over 4. Sine rather is -1/2. So 7 pi over 6 plus 2 pi n, or 4x minus, my x's are getting weird on the, it's always on like the right-hand side of the iPad screen where this happens. I don't know why. The other place would be 11 pi over 6 plus 2 pi n. And then we'll do n as an element of the integers. All right, so go with 12, I guess. 14 plus, so 14 pi over 12 plus 3 pi over 12 is 17 pi over 12, but then divide by 4, 17 pi over 48. Is it possible I should be showing more work? Probably. So that would give me this. So what did I say? It was over 12 and then over 4. So it's definitely over 48. It's 14 plus 3 is 7. I think that might be right. And then here is going to be 22, 25 pi over 48 plus pi over 2 times n, where n is an element. All right, we're going to check this, and then we are done with this page. But keep in mind what we did, because it's going to be a big part of the next 2 pages, basically. So essentially what we tried to do is create an angle that satisfied this, right? And for this problem, I had to divide by 2 to make sure I was getting cosines and sines, because root 2 and root 2, they're too big. They're bigger than 1. So I went with kind of what I knew, and it worked out. But like the problem was constructed so it would work out that way. So we got to figure out what to do in the event that that's not the case. But anyway, let's see if we can solve this. Solve square root of 2 sine of 4x minus square root of 2 cosine of 4x equals -1 for x. Expand. So you can see pi over 48. That's not what I got, but let's find out. Expand -7. Let me add. What am I supposed to add? I'm supposed to add pi over 2. 17 pi over 48. Yes. Okay. And then this other one. Why? Oh, you know what? That's weird. Let me expand this. Expand my answer. Pi over 48. Now, if I add pi over 2, which is like the period in this case, I get 25 pi over 48, which is what we got when we solved it. And why did we end up with like the weird version? I don't know. I mean, we didn't do anything wrong. I think it's probably the choice between like using negative pi over 6 and using positive 11 pi over 6, like which coterminal angle you're going to use to base your solution. And it makes sense the calculator would use a negative because it always does that for some reason. Anyway, we definitely got it, though we got a slightly different form of the answer. But that's okay because there's an infinite number of ways of writing it. So I'm going to cut this video here. I bet this is a long video. I don't really know. But it's an interesting topic, right? So this is kind of new. We have to do a couple weird things, but it's all stuff we're familiar with, thankfully. So I'll be back in the next video where we're actually just going to do more of this type of thing. So I will see you in the next one.